Astronomers were fortunate enough to bear witness to an extraordinary occurrence, the largest explosion ever recorded in space. The celestial event, given the name at 2021 LWX, surpassed the brightness of any known supernova, those tremendous bursts that mark the demise of massive stars. Unlike typical supernovae, which endure only a few months, this colossal explosion has persisted for a staggering 3 years. At 2021 LWX outshines the radiance produced when stars are torn apart and consumed by supermassive black holes, known as tidal disruption events or TDEs, by a factor of 3. The cataclysmic blast transpired approximately 8 billion light-years away from Earth, signifying that it took place when the universe was a mere 6 billion years old. Initially detected in 2020 by the Zwicky Transient Facility in California, at 2021 LWX was subsequently detected by the Asteroid Terrestrial Impact Last Alert System, ATLAS, based in Hawaii. These systems are specifically designed to survey the night sky, scrutinizing astronomical events that exhibit rapid fluctuations in brightness, commonly referred to as transients. Such changes in luminosity can indicate the presence of a supernova, a gamma-ray burst, GRB, or even objects closer to home like comets or asteroids. Despite being spotted by these observatories 3 years ago, the true extent of at 2021 LWX's scale and power remained unknown until now. We stumbled upon this phenomenon accidentally when our search algorithm flagged it while we were looking for a particular type of supernova, said Philip Wiseman, a research fellow from the University of Southampton who led the study. Most supernovae and TDEs fade away within a couple of months. Thus, for an event to remain brilliantly visible for over 2 years was immediately recognized as highly unusual. Wiseman and his team of astronomers propose that at 2021 LWX might have resulted from a violent black hole disruption of a gas cloud with a mass thousands of times greater than that of the Sun. As the black hole engulfed fragments of the gas cloud, shockwaves emanated through the remnants of the gas and a surrounding torus of dust, manifesting as intense electromagnetic radiation. While at 2021 LWX does not possess the same luminosity as the gamma-ray burst GRB 221009A, which astronomers observed in 2022 from a distance of 2.4 billion light-years, the latter event only lasted for a mere 10 hours after detection. Although 10 hours is relatively long for a GRB, the total energy output of at 2021 LWX throughout its lifespan far exceeds that of the gamma-ray burst. To assess the power of this cosmic explosion, the research team conducted further investigations employing various telescopes, including the Neil Gorell's Swift Telescope, the New Technology Telescope in Chile, and the Gran Telescopio Canarias in La Palma, Spain. These observations facilitated the collection of the emitted light spectrum, which was then analyzed to measure the manner in which light was emitted and absorbed in the vicinity of the event. Consequently, the researchers were able to determine the distance to the source of at 2021 LWX. Once the distance to the object and its apparent brightness are known, the intrinsic brightness of the object at its source can be calculated, explained Sebastian Honig, a professor from the University of Southampton and a member of the team. After performing these calculations, we realized that at 2021 LWX is remarkably luminous. The only entities in the known universe that match the brightness of at 2021 LWX are supermassive black holes. When these black holes devour stellar gases at high velocities, they emit incredibly brilliant emissions called quasars. With a quasar, we observe fluctuations in brightness over time, added Mark Sullivan, a professor from the University of Southampton and another member of the team. However, over the span of a decade, there were no detections of at 2021 LWX until it suddenly emerged with the luminosity surpassing that of the brightest objects in the universe. This unprecedented occurrence has left us astounded. While there exist alternative explanations for this explosive event, the astronomers currently favor the hypothesis that suggests the presence of an immensely large cloud predominantly composed of gaseous hydrogen or dust. This colossal cloud was dislodged from its orbit around the black hole and subsequently consumed by it. Further data collection is necessary to definitively confirm this theory. The team's next course of action involves examining the explosion across different wavelengths of light, including X-rays. Such analysis could provide insights into the event's temperature and the underlying processes driving it. Additionally, the researchers intend to conduct computer simulations to ascertain whether their model of a gargantuan gas cloud disrupted by a black hole aligns with the observations of a 2021 LWX. With upcoming facilities like the Vera Rubin Observatory's Legacy Survey of Space and Time, set to come online in the next few years, we anticipate discovering more events of this nature and gaining further knowledge about them, concluded Wiseman in the statement. These exceedingly rare but highly energetic events may play a pivotal role in understanding the evolution of galactic centers over time. In the depths of the night sky, a seemingly insignificant flicker caught the attention of astronomers. Little did they know that they were about to witness the largest cosmic explosion ever recorded, a mind-boggling event triggered by the voracious appetite of a supermassive black hole consuming a massive cloud of gas. Located a staggering 8 billion light-years away, this celestial flare-up surpasses any known supernova in brightness by more than tenfold. Lasting over 3 years, it stands as the most energetic explosion ever witnessed in the universe. Dr. Philip Wiseman, an astronomer from the University of Southampton, led the observations and revealed that the event went unnoticed for a year as it gradually increased in brightness. It was only when subsequent observations unveiled its immense distance that astronomers comprehended the unfathomable scale of this phenomenon. We've estimated it's a fireball 100 times the size of the solar system with a brightness about 2 trillion times the sun's, shared Wiseman. In 3 years, this event has released about 100 times as much energy as the sun will in its 10 billion-year lifetime. Scientists believe that the explosion, known as a 2021 LWX, originated from a colossal cloud of gas, possibly thousands of times larger than our sun, plunging into the inescapable grasp of a supermassive black hole. This gas cloud may have originated from the dusty donut that typically surrounds black holes. However, it remains unclear what caused it to deviate from its orbit and plummet into the cosmic sinkhole. While a 2021 LWX is not the brightest cosmic event ever observed, as a more radiant gamma-ray burst known as GRB 221009A was detected last year, its duration sets it apart. The new event has persisted for an extended period, leading to a significantly greater overall energy release. The initial detection of the explosion occurred in 2020 thanks to the Zwicky Transient Facility in California, which scans the night sky for sudden increases in brightness indicating cosmic events like supernovae or passing asteroids and comets. Initially, the event did not stand out, but subsequent observations enabled astronomers to calculate its distance and realize they had captured an incredibly rare occurrence. When I told our team the numbers, they were all just so shocked, Wiseman recounted. Once we understood how extremely bright it was, we had to come up with a way to explain it. Given that the brightness exceeded the plausible range for a supernova, astronomers turned to another possible cause of brilliant flashes in the night sky, a tidal disruption event. These events typically occur when a star strays too close to a black hole and is torn apart, with some of it being swallowed and the rest forming a swirling disk around the black hole. However, simulations indicated that a star, up to 15 times the mass of the Sun, would be required to account for a 2021 LWX. Encountering such a huge star is very rare, so we think a much larger cloud of gas is more likely, Wiseman explained. Supermassive black holes are typically surrounded by extensive halos of gas and dust. The researchers speculate that some of this material may have been disrupted, potentially due to a collision between galaxies, and drawn inward. As the material spiraled towards the black hole's event horizon, the spherical outer boundary, it would have emitted colossal amounts of heat and light, illuminating a section of the donut and heating it to temperatures ranging from 12,000 to 13,000 degrees Celsius.